card. It says that they're tiny. I had to make that box really small to fit everything else. Put your name up on here. It is second hour that we are recording this. Okay, very first thing, this is not specific to any section. This is specific to everything. Every answer on your entire test needs to be in standard form, which means highest to lowest exponent, constants at the end. So x to the fifth, x to the fourth, x to the third, x squared, x, no x's. So every single answer, the entire test, put them in standard form. 5.1, we classified polynomials and we combined like terms. When we are classifying, you classify based off of the degree first, which is our highest exponent. Your classification's based off of degree. Degree of 1 is linear, L-I-N-E, line, A-R. Degree of 2 is a quadratic, Q-U-A-D, quad, rat, R-A-T. I-C. Ick. Quadratic. Write neatly enough that you can read your own handwriting on your test. Degree of 3 is cubic, cub, like a bear cub, ick. And degree of 4 is quartic, Q-U-A-R-T, like a quart of milk, ick. Okay, so we classify based off of degree. And then we can also classify based off of number of terms. One term is a monomial. Two terms is a binomial. Three terms is a, well, I can't white out because this isn't white paper. Trinomial. The T looks weird. And 4 or more terms. So there's a plus sign there. 4 plus. Once you get to 4 or more, it is a polynomial. Poly just means many. Okay, and then the last thing here for 5.1, when we combine like terms have the same variable and exponent. So that's what we're combining together. Okay, I know the blanks on this are kind of small because it's a note card and we're trying to fit 9 sections worth of stuff on there. So we used to have people make their own note cards and 80% of people would leave them completely blank, and 20% of people would spend an hour fitting the entire review and writing tiny and not being able to read any of it. So we figured neither of those were useful. So a couple years ago, we started doing note cards for you. In future math classes, you might be told, hey, you can use a note card or a half sheet of paper to put notes on. So this is kind of like us trying to train you and give you some ideas to, like, if you were to look through your notes, these would be the things that are on your notes that you could put on a note card. Linnea, does geometry let you use a note sheet?
Yes.
Yeah, but you have to make it yourself. So this is a skill that we're trying to instill in you. So look at the types of things we put on here. So the tables of info, an example from a different section, another little table of info. So next year in geometry, when you guys are trying to make a note card, flip through your notes and find all of those important tables of info and put them on your note card. Pick an example from each section, put it on your note card, okay? All right, sorry, that was a little bit of a sidebar. Moving on, 5.2 is to the right. 5.2, we added and subtracted polynomials. When we add and subtract, We combine like terms by adding together their coefficients. We do not add the exponents. It says it right below there. Don't change the exponents. We're just adding the coefficients. So for addition, we didn't put an addition example on here because for addition, you just combine like terms. For subtraction, you have to remember to distribute the negative to the entire second set of stuff. So I'm going to put an imaginary -1 there, and I'm going to distribute that. -1 times 7x cubed is -7x cubed. -1 times 8x squared is -8x squared. And then -1 times -3x, negative times negative is positive 3x. Okay, any questions about that distributing? Okay, so now we get to combine like terms. And we want to put it in standard form from the get-go so we don't have to go back and fix that. So the highest exponent I see is x to the third. So I'm going to put that first, -7x to the third. I'm going to underline it so I know I've used it. Then I would do my x squareds. Right here I've got 8x squared and -8x squared. What happens to those? They cancel out. What do you write down? Nothing. One of our worst habits we have, like collectively, or not worst habits, but one of the most common mistakes I see being made still is people writing down x there, or x squared. 8 minus 8 is 0, not 1. Okay, then right here, 3x and 3x. 3x plus 3x is 6x. That does not cancel, because they're both positive. And then my -5 can go at the end. Okay. Any questions about that guy? Okay. The front side of the note card kind of goes in a little clockwise circle because from here we go straight down for multiplying. For multiplying polynomials, you multiply your coefficients, you add your exponents. We did not put an example of 5.3 because those are ones where you just distribute and you guys are really good at these. We did put an example of 5.4. 5.4, this is when you could have used that little 2x3 table. So if you want to use a 2x3 table, you are welcome to. We're just going to distribute out because I think that's what most of us are doing now. Before we do that, if you have an x by itself, it's 1x to the first. If you have a negative x by itself, it's -1x to the first. So on that note, I'm going to go ahead and put in my imaginary ones. 2x to the first, -2x to the first. Right there. Okay, what is 2 times 3? 6, okay, yeah. So if I have a binomial 2 terms times a trinomial 3 terms, I should end up with 6 terms before I combine anything. So if you're using the boxes, then you should be able to just see I filled up all my boxes. If you're not using the boxes, maybe go back and count before you combine like terms to make sure you didn't miss anything, because it's easy to miss things. Okay, so we are going to do 2x to the first times 3x squared. 2 times 3 is 6. I add my exponents. 1 plus 2 is 3. So I've got 6x cubed. Then I do 2x to the first times -2x to the first. 2 times -2 is -4. I add my exponents. 1 plus 1 these days is 2. So I've got -4x squared. And then 2x to the first times 5. 2 times 5 is 10. And then 1 plus none is 1, so I still have my x to the first. Should have started further to the left. I'm going to run out of space here. Any questions about those first 3 terms? Okay, so I always do the first guy times all of these, then I do the second guy times all of these. So if we were doing the box, this would be your top row, and now we're doing what would be your bottom row. Negative 3 times 3x squared is negative 9x squared. Negative 3 times negative 2x. Negative times negative is positive 6x to the first. And then I'm running out of space. Negative 3 times 5 is negative 15. Okay. Any questions on that guy? Okay. So before I combine, I like to check. I've got 1, 2, 3, 4, 5, 6 terms. Now I can combine. My 6x cubed stays at the beginning by itself. And then I can combine my negative 4x squared and my negative 9x squared. Negative 4 and negative 9 is negative 13x squared. Don't change your exponents. You're just combining your coefficients. And then 10x and 6x is 16x. And then I've got my minus 15. Okay. Any questions about that guy? All right, we are going to get done with this side then, and then, yeah, we're going to get done with this side. Okay, last thing on this side, 5.5 is greatest common factor. For greatest common factor, we identify the GCF, the greatest common factor, the biggest thing we can divide everything by, out of the polynomial, and then we factor it out by dividing your coefficients and subtracting your exponents. So out of 3, 9, and 12, what can I divide all those by? 3. Okay, then I have x to the fourth, x squared, and x to the imaginary first. How many x's can I pull out? Just x to the first. Awesome. So my GCF here is 3x to the first. I'm going to put that in front of parentheses. And then I'm going to start dividing it out. 3 divided by 3 is just 1. I subtract my exponents. 4 minus 1 leaves me 3. Negative 9 divided by 3 is negative 3. Subtract my exponents. 2 minus the 1 leaves behind 1. And then my last term, 12 divided by 3 is 4. 1 minus 1 leaves behind no x's. You should always factor out all of the x's from your last term. Okay. Any questions on that guy? Okay, next one, 15, 25, 55. What can I divide all those by? 5. We put that 55 there on purpose because people are not understanding that 55 divided by 5 is 11. Okay, then how many x's can we take out? None, because that 55 doesn't have any. So on this one, our GCF is just 5. We put this one on here on purpose because it's a common mistake we're seeing. So 15 divided by 5 is 3. I still have my x to the 6th. Negative 25 divided by 5 is negative 5. I still have my x to the 3rd. And then 55 divided by 5 is 11. All right, I'm going to pause this video because this unit is so long and has so many details in it that we've been going for a long time. and I feel like I'm starting to lose some people. So I want to give you guys your reviews, give you a chance to work on your reviews, and then we will do the back of this note card in like 20 minutes, okay? Hey, so the back side of this note card is the rest of our factoring stuff. So 5.5 was factoring, and then everything else is factoring. We reviewed all of this Tuesday, whatever day I saw you, when we did our factoring organizer. So we've seen all of this twice already now, and now we're seeing it for a third time. This table is the table you can use in 5.6 and 5.9. In 5.6, you're trying to multiply to C, and 5.9, you're trying to multiply to AC. Then you can also use this X for either. So we're going to do this 5.6 one first. If A equals 1, there's no number in front of X squared. We just have to find two numbers that multiply to C and add to B. Multiply to add to the negative 8. So we are trying to find two numbers that multiply to 12, and we need them to add to negative 8. So you can use your magic X, and or you can list out your factor pairs. What numbers multiply together to be 12? 1 and 12, 2 and 3 and 4, and then since 4 is on the other side of the list already, we know we're done. Okay, if you look at your table up above, we see that we are trying to add to negative and multiply to be positive. So looking at your table up above, add to negative, multiply to be positive, we want to pick two numbers that are both negative. So I'm going to make everybody negative. And then which ones of these add together to be negative 8? Negative 2 and negative 6. So those are the two numbers I would pick. And I would write my answer as x minus 2 times x minus 6. Okay. You do not need to show work on these, but showing work might be a way to get yourself partial credit if you are close but not completely accurate. So, just FYI, BTW. This is what we're working on right now. Hey, any questions? Did you check in? At the office? Okay, you need to go check in at the office then. Hey, next one. We are going to scoot all the way up to the top right-hand corner. Difference of squares was the next thing we did. So difference of squares is difference is subtraction, perfect squares. So subtraction of two perfect squares. Right here, what number times itself is 4? 2. And then x squared is x times x. So we're going to need an x along with that. So right here, my a is 2x. What number times itself is 81? 9. So we are going to write our answer as 2x plus 9 and 2x minus 9. 5.6 and 5.7 are the only two sections where you wouldn't need to show work. You can do that without showing any work. Like, you can do that in your head. You can show work if you want to, but you don't have to. Any questions about that? Okay. Moving straight down then to 5.8, and then we'll move back over to 5.9. It's just the way things fit. 5.8 was factoring by grouping. We can do this when there's 4 terms. Here are our steps. If you have a note card that's from the top half of the page, it says 1, 2, 3. If you have a note card that's from the bottom of the half of the page, because they print 2 per page, I forgot to restart the numbering. So it says 4, 5, 6. If you care and want to change it to 1, 2, 3, you can. Okay, so step 1 is to factor the GCF out of the first 2 terms. And step 2 is to factor the GCF out of the last 2 terms. And then what's left behind should get to match. What can I divide 2 and negative 4 both by? 2. I am never going to pull a negative out of my first 2 terms, because my first term is never going to be negative. That one might be, but that one will never be. I can also pull out an x squared, because I've got 3 here and 2 here. So 2x squared is my first GCF. 2 divided by 2 is 1. And then I can subtract my exponents, 3 minus 2, also 1. So I've got 1x to the first there. Negative 4 divided by 2 is negative 2. And then I subtract my exponents. 2 minus 2 is none. Okay, is there anything I can divide out of negative 1x and positive 2? So the only thing I can divide out is a 1, and in order to leave behind the same thing, I need to divide out a negative 1. So my second GCF is going to be negative 1. So negative 1x divided by negative 1 leaves behind a positive x. 2 divided by negative 1 leaves behind a negative 2. Okay, what's left behind matches. I know we have our imaginary ones here and we don't here, but it's still the same thing. So I've got x minus 2. And then the other piece of my answer is this 2x squared and this minus 1. They go together as my other factor. Okay. Any questions? Okay, we've got one more problem to do together, which is our 5.9. So I'm going to scoot back over. This is what we do if we have a number in front of x squared. So if we have a number in front of x squared, we need to find two numbers that multiply together to be a times c and add together to be b. So I'm going to label my a, b, and c. So I think that's helpful. And in this problem, a times c, ac, is 5 times negative 3, which is negative 15. So I am looking for two numbers that multiply to negative 15, and they need to add together to be negative 2. I feel like we've done this before, like this specific problem. Maybe we have. I don't know. What numbers multiply to 15 and are 2 apart from each other? 5 and 3, or 3 and 5? So let's write those down. I'm going to put down 3 and 5. We need one to be negative to multiply to be negative. Do we want the smaller one or the bigger one to be negative? What are we trying to add to? A negative. So if you're trying to add to a negative, you want your bigger one to be negative. So we'll make the 5 negative. All right, so then, splitting up my middle term, I've got 5x squared, which will stay the same. I'll split my middle term up into plus 3x minus 5x. So I'm like uncombining like terms. And I still have my minus 3 here. I'll draw a line. Okay, then I can factor by grouping. 5 and 3, we can't divide anything by, or we can't divide by anything other than 1, but we can pull out an x. So 5x squared, pull out an x. Leaves behind the 5 and the other x. 3x, pull out an x. Leaves behind the 3. And then this negative 5x minus 3. Can't divide 5 and 3 by anything, but since they're both negative, and I want to leave behind positives, I am going to divide by a negative 1. So negative 5 divided by negative 1, positive 5x. Negative 3 divided by negative 1, positive 3. Okay, so then we have our matching guys, 5x plus 3. The other piece of our answer is this x minus this 1. Hey, I am going to go ahead and pause this video so I can get it uploading. Unit 5 is a lot, but